Hello and welcome to this video about pandas for data handling. We're excited to have you here, and in this video we're going to talk about pandas operations and techniques and teach you how to inspect the contents of a data frame using the practical pandas head and tail functions, and some more. The pandas head and tail functions are very useful when you use very large data frames, which are very common within the current data science and machine learning data paradigms. The head function displays the top part or first n rows of a data frame. The tails function is the opposite of the head function and makes you able to inspect the last part of a data frame or the n last rows of a data frame. The head and tail functions are excellent tools to inspect pandas data frames, and this means that the head and tail functions enable you to experiment with your functions, and that you can use the heads and tails functions to see a small part of a possibly very large data frame, and the results of your experimentations, of course. In practice, this is a very useful tool because you don't have to load and print the entire data frame, and you can look at the first 10 or 20 or last 10 or 20 rows of the data frame to see what effect your function had on the data frame. And this is a very useful tool as you don't have to wait for a screen print of a large data frame, plus consuming memory and resources, but easily can check if the function you applied to the data frame really did what you expected it to do. And these inspection functions are useful, time-saving, and very simple to use. And now we're going to type some code, so start up your code editors. All right, having started our Jupyter Labs notebooks, we are now going to type some code. And this time we have our standard car sales data frame, but we have made some changes to it. So we will not rename the index labels, and we will create 5,000 copies of the data frame and put them one after another. So we will still have 4 columns, but we will have the 6 sales places multiplied by 5,000. We will have 30,000 sales places. And we do this for the single purpose of demonstrating why the head and tails function are necessary for inspecting data frames. We will run this code. And here we can see that the printout is so large, and presumably the print function with the data frame and Jupyter Labs notebook is designed to use the head and tails function for this standard printout. So let's begin. And we can try the head function. And we know that 5 is the default. We type print car sales n head. And let's run this code. And here we can see that we had a printout of the 5 first rows of the data frame. 20 rows can be a useful inspection number. We type print car sales n head, and we give it 20 as an argument. So let's run this code. And here we can see the first 20 rows of our car sales N data frame. And this is a useful number of elements to check the performance of, for example, an experiment on the data frame. And we can type that the tail function shows the bottom of the data frame. We type print car sales N tail, and we add 20, and we run this code. And here we can see the 20 last element of the data frame. So now we know how to inspect the first 20 elements and the last 20 elements. But what if we want to inspect a selection from the middle, somewhere the data frame? We can try the iloc function. So we type car sales N iloc, and we can inspect element 5000 to 5020. All columns. Like this. So let's run this code. And here we can see an inspection output of row number 5000 to 5020. And if you want to inspect another range within the data frame, we just change the numbers within the brackets here. So this is a very useful function for inspection, and we will look at this iloc function more in column and row selections later. But now we will check if we can print the entire car sales data frame as a string. And we must note that this is not a recommended option for large data frames. And the reason can be checked by adding a 0 or 2 to the 5000 value in the first cell of this notebook. And when you run the code, you will either get a warning message or a crash. And this will depend on your hardware, your software, your settings, and the programs which you run. So for example, if you run it in the cloud, you might get a warning message that you will use a large number of resources. And if you run it on your private computer with, for example, 8 or 16 or 32 gigabytes of RAM, or even more perhaps, or less, you might get a crash depending on which value you choose to add to the number 5000. Now we'll type print car sales N to ring. And let's run this code. And here we can see that in this case, the size of the data frame fit the memory and the settings of the Jupyter Labs notebook. And this is just in this case. So this is a very bad practice because in most real life cases, you will not know whether you are going to fit the parameters or not, unless you have made a very careful investigation of the matters. And we have some other options. So you can use various functions to iterate through the data frame and print every row. And there is no good solutions without either relaxing safety parameters of the software or using imported vectorization techniques or libraries from other coding libraries or languages. Let's try a Python iterator. And it is slow, cumbersome, and turns every row into a tuple and print the tuple for tuple. We type for row in car sales n iter tuples print each row. So let's run this code. And here we can see that every row in the data frame was turned into a tuple and printed to screen. And we have some other options. So we can import more developed visualization libraries. We type from IPython display import display. And we type pd set option display max rows none. And we will display our car sales data frame. And we type pd reset option display max rows. And here we could type PD, reset options, all. So what this code will do is that it will import the display function from the IPython library. It will relax a safety parameter and set it to none, remove the display max rows safety parameter, which intends to prevent crashes and overuse of RAM memory. And we will display our car sales data frame. And finally, we will reset, or rather restore, this safety parameter max rows. So let's run this code. And here we can see a very nice, modern and graphical outprint of our data frame. So this is the other alternative. And we can say that the computers, depending on the hardware, software settings, and other parameters, may crash even when trying to print or look at even modest data frames or similar data items. And this is why we need the head and tail functions. Plus, of course, some assistance from functions such as the iLocate function, the locate function, and support libraries. In order to properly inspect the contents of data frames. In the next video, you will learn about the Pandas data frame column, feature, or variable selections. And we look forward to see you in the next video.